Hello and welcome. Today we're going to be going through the bowling game scoring kata to see the test-driven development flow at work creating clean, extensible code. Since we're doing TDD, let's begin by removing our speckle boilerplate and writing our first test. So in this case, the simplest test case that we can start off with is simply a game of gutter balls, which of course we need to score as 0. So we might start off with some sort of score function, which takes in some sort of sequence of rolls, in this case 20 zeros. We're not very good at bowling. And if we run our tests, you will see that we get a lovely compilation error, which is exactly what we expected. So the complaint to the compiler was that there was no score game function. So let's write the smallest amount of code which will make this test pass and simply return 0. And if you look now, we're now in the green. This code isn't particularly useful for us though, so let's think about the simplest test which will make us actually start implementing this function. So let's start actually rolling some pins and verify that we score a game of single pin rolls as 20. And just as expected, when we go and run our tests, it fails because we are simply returning 0. So the smallest amount of code, which might make this pass now, is to simply sum up the value of all of the rolls, like so. And if we run our tests, we can now see that we are in the green. Now, for good measure, let's test a situation where we don't roll the same number of pins each roll. But if we go and try to, say, roll a bunch of 2s and 3s, we'll see that we don't really have the infrastructure to do this yet. So let's comment that out and refactor. Our problem in our most recent test is that we need to be able to continue to append more and more rolls onto an existing list. So let's make a function called rollMany, which allows us to pass in a list of rolls, a number of pins, and a number of rolls so that we can chain these calls together to call unique sequences of rolls. And we can actually use these functions in our previous tests as well. So let's rollMany, passing in an empty list, and sure enough our tests pass. And same thing for rolling a sequence of 21s. Fantastic, still in the green. All right, so now let's thread through that empty list and first roll, say, 10 2s. And then after that, we can thread that result to 10 3s. I still think that these tests could read a little bit more naturally though. So let's take that empty list and actually describe it as a new game, just to be a little bit more expressive. Fantastic. So we've now dealt with scores less than 10, but what happens if we score a spare? So we need to give the bonus from the next frame to the current frame. So let's say we roll a spare and then a 3. So that should give us 13 for the first frame and then score the next frame as 3, giving us 16. And of course this test fails because we've been simply accumulating the rolls with our score function. So what this test has revealed to us is that we might have been thinking about the problem wrong. Instead of a roll by roll basis, we need to think of it on terms of a frame by frame basis. So let's refactor this and loop through, instead of by roll, by frame. So we can pass in rolls and accumulate a score. And then if there are no more rolls, of course, just give us the score. But otherwise, let's recursively go ahead and not just give the next rolls, but the next rolls. So go forward 2, and each frame accumulate the first of those values and the second of those values. Now we can be confident that our code is still doing what we want it to do based off of the fact that all of our tests are still passing, but it's a bit verbose, so let's clean it up. Now this next business is a little bit unclear, so let's refactor this out to a function which describes what it's really doing, which is progressing to the next frame. If we pass in our rolls, we can see that our test should still pass, and just reading the function, it's a little bit more clear what's happening. And we can actually do the same thing here with the score accumulation, just to make it read a little bit more naturally when we're taking a look at the score game function. And making sure that our tests still pass, let's now go readdress the spare issue. So if we uncomment our test, we'll of course see that the test fails. And so what we have to do is when we score the frame, we need to first check and see if our frame possesses a spare. So if the sum of the first roll and the next roll are 10, well then we need to give that bonus, that 10 plus the third roll after. And otherwise scoring it normally, now our test pass. Now by our prior standard, this code isn't very expressive, so let's factor out the code that checks if our frame has a spare and put that in a more descriptive function and pass in rolls. And lo and behold, our test passed. Now, it's always good to make sure that our edge cases are covered, so let's take the spare code and assume that we roll a full game of spares, which will have us actually roll one additional roll for a total of 21, and sure enough, our test passes. Very good. All right, now let's move on to scoring a strike. So if we roll a strike, we need to give a bonus for the next 2 frames. So let's start off with a new game and say that we roll a strike, and then we maybe roll a 2 and a 3. So that'll score 15 total on the first frame plus the 2 and the 3 for a total of 20. Now, of course, our test fails because we haven't implemented that yet, so let's go back to the code. So before checking for a spare, we need to first see if the first roll is a 10, which means we get a strike, and in that case we add 10 to the next roll as well as the roll that comes after it. And then otherwise, we can check if it's a spare, and of course otherwise we can just score normally. But if we look at our test, it's actually still failing, but with a different value. We're getting 18 instead of 20. It looks as if we're giving the correct bonus for the 10 by adding the 2 and the 3 for 15, but then going and skipping the 2 and only adding the 3 for the scoring of the next frame. And of course, this is because when we progress the frame, we always iterate 2 rolls each time, whereas if we roll a strike, we actually only want to progress 1, since the strike is the only roll that we score for that frame. So going into the progress frame function, we can simply add a condition here, check if it's a strike. If it is, only go 1 roll forward, otherwise go the normal 2 to progress the frame. And sure enough, our test passes. But this change that we've made has created some code duplication, so let's pull out the code that checks if the frame contains a strike, and much like the spare, split that out into its own function. So now, both in progress frame and in our score frame functions, we can call that function instead. And as you can see, our tests still pass, but now our score frame function has become sort of verbose. So let's break out the scoring for a strike into its own function, which we can very expressively just call right there. Test pass, and while we're at it, let's go ahead and do the same thing for the spares as well. I can just call the function in score frame, and all of our tests pass. Fantastic. So let's do now what we did for the spares and address what happens in the final frame by testing what happens when we score a perfect game, which should come out as 300. But as we run our tests, we will see that we actually get an index out of bounds exception. Where might this be happening? Well, if we look at our score game function, we check to make sure that the next roll is not null, after which we then potentially score a strike. However, in the score strike function, we actually check 2 rolls ahead, which in the last frame will be null. So let's define a symbol here called last frame and make it evaluate to a Boolean value that indicates whether or not the next frame is null. If it is, simply return 0. Otherwise, score the strike normally. And sure enough, if we run our tests, they all pass. And so we can be extremely confident that our program scores bowling games correctly because of the extensiveness of our test suite.